It is a code violation to install conductors with a 105 degrees Celsius temperature rating in PVC conduit that is only rated for 90 degrees Celsius. This is because the temperature rating of the conductor exceeds the temperature rating of the conduit, and such an installation would not comply with the electrical codes. However, some manufacturers do produce PVC conduit that is rated for 105 degrees Celsius. Therefore, it is essential to check the temperature rating of the specific conduit being used before installing conductors with a high temperature rating like 105 degrees Celsius. The National Electrical Code, or NEC, provides guidelines for the proper installation of electrical systems, including the selection and use of appropriate wiring methods and materials. One crucial aspect of electrical installations is ensuring that the temperature ratings of conductors and conduit are compatible. Conductors generate heat as electrical current flows through them due to the resistance of the conductor material. This heat must be dissipated to prevent the conductor insulation from degrading and potentially causing a short circuit or other electrical hazard. The maximum temperature that a conductor can safely withstand is determined by its insulation rating. Common conductor insulation types include THHN, THWN, and XHHW, each with different temperature ratings. For instance, THHN and THWN conductors are typically rated for 90 degrees Celsius in dry locations and 75 degrees Celsius in wet locations, while XHHW conductors may be rated for 90 degrees Celsius in both wet and dry locations. Conduit is a protective raceway used to enclose and protect electrical conductors. It is typically made of metal or plastic, such as PVC. Conduit also has a temperature rating that indicates the maximum temperature it can withstand without degrading or deforming. PVC conduit, for example, is commonly rated for 90 degrees Celsius. The NEC requires that the temperature rating of the conduit be equal to or greater than the temperature rating of the conductors installed within it. This is to ensure that the conduit can adequately protect the conductors from overheating and potential damage. When selecting conductors and conduit for an electrical installation, it is crucial to consider the ambient temperature of the environment in which the installation will be located. The ambient temperature is the temperature of the surrounding air or medium. In hot environments, the ambient temperature may be high enough to affect the temperature of the conductors and conduit. The NEC provides ampacity correction factors that must be applied to the allowable ampacity of conductors when the ambient temperature is above 30 degrees Celsius. These correction factors reduce the allowable ampacity of the conductors to account for the increased heat generated at higher ambient temperatures. In addition to ambient temperature, the number of conductors installed in a conduit can also affect the temperature of the conductors. When multiple conductors are installed in a conduit, they generate more heat than a single conductor. The NEC provides adjustment factors that must be applied to the allowable ampacity of conductors when more than 3 current-carrying conductors are installed in a conduit. These adjustment factors reduce the allowable ampacity of the conductors to account for the increased heat generated by multiple conductors. When installing conductors in conduit, it is also important to ensure that the conduit is properly sized. The NEC specifies the maximum number of conductors that can be installed in a given size of conduit. Overfilling a conduit can restrict airflow and increase the temperature of the conductors. In situations where high-temperature conductors are required, such as in industrial applications or environments with high ambient temperatures, it may be necessary to use special high-temperature conduit. High-temperature conduit is typically made of metal such as steel or aluminum and is designed to withstand higher temperatures than standard PVC conduit. In addition to temperature ratings, it is also important to consider the voltage rating of conductors and conduit. The voltage rating of a conductor indicates the maximum voltage that it can safely carry. The voltage rating of conduit indicates the maximum voltage that it can safely insulate. The NEC requires that the voltage rating of conductors and conduit be equal to or greater than the voltage of the electrical system in which they are installed. When selecting conductors and conduit for an electrical installation, it is essential to consult the NEC and other relevant standards and regulations. These resources provide detailed information on the proper selection, installation, and use of electrical wiring methods and materials. It is also important to work with a qualified electrician who is familiar with the NEC and other applicable codes and standards. A qualified electrician can ensure that the electrical installation is safe, reliable, and compliant with all applicable regulations. Furthermore, it's important to distinguish between different types of conductor insulation. THHN and THWN are common types, but their suitability depends on the application and environmental conditions. THHN is suitable for dry locations, while THWN is suitable for wet locations. Some conductors are dual-rated, such as THHN/THWN, meaning they can be used in both dry and wet locations. When using dual-rated conductors, the lower temperature rating must be observed. For example, if a THHN/THWN conductor is rated for 90 degrees Celsius in dry locations and 75 degrees Celsius in wet locations, the 75 degrees Celsius rating must be used when the conductor is installed in a wet location. Additionally, the type of equipment connected to the conductors must be considered. Some equipment may have specific temperature limitations that must be observed. For example, some luminaires may be rated for a maximum conductor temperature of 75 degrees Celsius. In such cases, the conductors connected to the luminaire must have a temperature rating of at least 75 degrees Celsius. Another important consideration is the dating of conductors. As mentioned earlier, the NEC requires that conductors be dated when the ambient temperature is high or when multiple conductors are installed in a conduit. The dating factors are specified in the NEC and must be applied to the allowable ampacity of the conductors. It's crucial to understand that dating reduces the amount of current that a conductor can safely carry. Therefore, it's important to select conductors with an ampacity that is sufficient to handle the load after dating. When selecting conduit, it's also important to consider the type of environment in which the conduit will be installed. PVC conduit is suitable for many applications, but it may not be suitable for environments where it will be exposed to extreme temperatures or corrosive chemicals. In such cases, metal conduit may be a better choice. Metal conduit is more resistant to heat and chemicals than PVC conduit. It's also more durable and can provide better protection for conductors. However, metal conduit is also more expensive and more difficult to install than PVC conduit. Therefore, it's important to weigh the pros and cons of each type of conduit before making a selection. In addition to the temperature rating of the conduit, it's also important to consider its trade size. The trade size of a conduit refers to its internal diameter. The NEC specifies the maximum number of conductors that can be installed in a given trade size of conduit. Overfilling a conduit can make it difficult to pull conductors through the conduit and can also increase the temperature of the conductors. Therefore, it's important to select a trade size of conduit that is large enough to accommodate the number of conductors being installed. When installing conduit, it's important to follow all applicable codes and standards. The NEC provides detailed instructions on how to properly install conduit. It's also important to use the proper tools and equipment when installing conduit. Using the wrong tools or equipment can damage the conduit or conductors and can also create a safety hazard. Finally, it's important to inspect the completed installation to ensure that it is safe and compliant with all applicable codes and standards. A qualified electrician can perform this inspection and can identify any potential problems. Remember that electrical work can be dangerous, and it's always best to consult with a qualified electrician before starting any electrical project. It is crucial to ensure the correct ampacity of the conductors for this specific application. Ampacity refers to the current carrying capacity of a conductor, which is the maximum amount of current that a conductor can safely carry without exceeding its temperature rating. The ampacity of a conductor is determined by several factors, including the conductor's size, material, insulation type, and the ambient temperature. The NEC provides tables that list the ampacity of various conductors under different conditions. These tables should be consulted to determine the appropriate ampacity for the conductors being used in a particular installation. The ampacity of a conductor must be equal to or greater than the load it is intended to carry. The load is the amount of current that the electrical equipment connected to the conductor will draw. The load can be calculated by dividing the equipment's wattage by its voltage. For example, a 1200 watt appliance connected to a 120 volt circuit will draw 10 amps. In addition to the load, the ampacity of a conductor must also be sufficient to handle any potential overloads. An overload occurs when the current flowing through a conductor exceeds its ampacity. Overloads can be caused by various factors, such as starting a motor, plugging in too many appliances, or a short circuit. Overloads can damage the conductor and can also create a fire hazard. To protect against overloads, the NEC requires that conductors be protected by overcurrent devices, such as circuit breakers or fuses. Overcurrent devices are designed to trip or blow when the current flowing through them exceeds their rating. The rating of the overcurrent device must be less than or equal to the ampacity of the conductor it is protecting. When selecting conductors and overcurrent devices, it's important to consider the nonlinear loads that may be present in the electrical system. Nonlinear loads are loads that draw current in a non-sinusoidal waveform. Examples of nonlinear loads include electronic ballasts, variable frequency dryers, and computers. Nonlinear loads can generate harmonic currents, which are currents that are multiples of the fundamental frequency of the electrical system. Harmonic currents can overload conductors and can also cause other problems, such as voltage distortion and equipment overheating. The NEC provides guidelines for directing conductors that supply nonlinear loads. These guidelines should be consulted when selecting conductors for circuits that supply nonlinear loads. Grounding and bonding are critical for electrical safety. Grounding is the process of connecting the electrical system to the earth. Bonding is the process of connecting all of the metal parts of the electrical system together. Grounding and bonding help to protect against electrical shock by providing a low impedance path for fault current to flow back to the source. When a fault occurs, such as a short circuit, the fault current will flow through the grounding and bonding system back to the source. This will cause the overcurrent device to trip, interrupting the flow of current and preventing an electrical shock. The NEC specifies the requirements for grounding and bonding electrical systems. These requirements must be followed to ensure that the electrical system is safe. Surge protection is another important aspect of electrical safety. Surges are sudden increases in voltage that can damage electrical equipment. Surges can be caused by various factors such as lightning strikes, power outages, and switching of electrical equipment. Surge protective devices, or SPDs, are designed to protect electrical equipment from surges. SPD work by diverting the surge current to ground, preventing it from reaching the equipment. The NEC recommends that SPD be installed at the service entrance and at any other location where electrical equipment is vulnerable to surges. Electrical inspections are an important part of ensuring that electrical installations are safe and compliant with all applicable codes and standards. Electrical inspections are typically performed by qualified electrical inspectors. Electrical inspectors will inspect the electrical installation to ensure that it meets all of the requirements of the NEC and other applicable codes and standards. If the electrical installation passes inspection, the inspector will issue a certificate of compliance. A certificate of compliance is proof that the electrical installation is safe and compliant with all applicable codes and standards.